The spring is now compressed twice as much to delta x equals 2d. A student is asked to predict whether the final position of the block will be twice as far at x equals 6d. The student reasons that since the spring will be compressed twice as much as before, the block will have more energy when it leaves the spring, so it will slide farther along the track before stopping at position x equals 6d. So let's just think about what the student is saying, or what's being proposed here. So in the first version, the first scenario, we compressed the spring by d, and then the spring accelerates the block, and then right when we get back to x equals 0, all of that potential energy has been turned into kinetic energy, and then the friction is acting against the motion of the block, so you can view it as it's providing negative work. It's the direction of the force is opposite to the change in x, and that negative work eventually causes the block to stop. And all of that kinetic energy has now turned into heat, and so the block goes 3D. Now this new scenario, we could call that scenario 2, we are going to compress the spring twice as far. So now we're going to compress the spring twice as far. So we're going to compress it by 2d. So this is x equals negative 2d here. And what's being said, or what's being proposed by the student is, all right, if we compress it twice as far, all of this potential energy is then going to be, we're definitely going to have more potential energy here because it takes more work to compress the spring that far. And then all of that more potential energy is going to be converted to more kinetic energy once we get back to x equals 0. And so not only will it go further, but they're saying it'll go exactly twice as far. So we are going to go, instead of going to 3D, we're now going to go to 60. Now let's see what the questions are here. And actually let me put a question mark here since I'm not sure if that is exactly right. So part B1, let me do this. So we're in part B1. It says, which aspects of the student's reasoning, if any, are correct? Explain how you arrived at your answer. And then part 2 says, which aspects of the student's reasoning, if any, are incorrect? Explain how you arrived at your answer. So the student is correct that 2 times, so compressing spring more will result in more energy when the block leaves the spring, result in more energy when block leaves the spring, which will result in the block going further, which will result, or the block going farther, I should say, which will result in longer stopping distance, which will result in longer stopping distance. Now, part 2 here. Which aspect of the student's reasoning, if any, are incorrect? Explain how you arrive at your answer. Well, 2 times, I could say, let me say, compressing twice as much does not result in exactly twice the stopping distance. Does not result in twice the stopping distance. The stopping distance. And we can explain more if we like. We know that potential energy is equal to 1/2 times the spring constant times how much we compress squared. So we can say that energy grows with the square of compression, of how much we compress it, of how much we compress. So 2 times the compression, let me say 2 times, I'll write it out, 2 times compression will result in 4 times the energy, and this will result in 4 times the stopping distance. 4 times stopping distance. 4 times stopping distance. I think that does a decent job of explaining where the student is correct, where their reasoning is correct, and where it is incorrect.